Hey, geometry. We're starting section 7.1 today. Tomorrow when I come back, I'll give you back your tests, and then we'll just keep moving along in section 7.1. But 7.1, or chapter 7 itself, is kind of, I don't know what you think about when you think of geometry. So we're doing geometric figures, parallelograms, rectangles, kites, squares, that type of thing. This section is more focused on the angles. So we do one section on angles, and then we talk about the geometric figures themselves in section 7.2 and beyond. In this first little bit or little piece of information that they give to you, we have actually done this process before. So I'm going to write some stuff off to the side over here. When we deal with a triangle, okay, we know that inside of a triangle, no matter what it looks like, it has 180 degrees, okay? Like all the angles added up together will be 180 degrees, okay? I should put like not the same number of tick marks. All of them add up to be 180 degrees. Now, if I have a quadrilateral, so it doesn't necessarily have to be like a square or anything. It has 4 sides and 4 angles. These 4 angles are going to add up to be 360 degrees. And the reason for that is that if I, let's say, draw a diagonal like across there, or I could draw it across here, it doesn't matter, right? When I do that, I will end up with a triangle up here at the top and a triangle up here at the bottom. So if I have a 4-sided figure, I have 2 triangles, and each of those 2 triangles is 180 degrees, and that gives me 360, okay? Let's say I have a 5-sided figure, okay? Like a pentagon. Okay, it doesn't have to be a regular pentagon where all of the sides are equal. I just have 5 sides, 5 angles. If I add up all 5 of these angles, okay, I can figure out how many degrees those will add up to be, because if I draw diagonals, I will have 1, 2, 3 triangles. So a 5-sided figure equals 3 triangles, and I would just take 3 times 180, because each one of those triangles is 180, right? And that is end up being like 540. Right? So all of these angles added together would end up being 540, and so on and so forth. I could do the same thing with a 6-sided figure, 7-sided figure, 8-sided figure, whatever, right? Okay, the rule is that however many sides I have, I subtract 2, and that's how many triangles I have, right? 4 minus 2 is 2 triangles, right? So the number of triangles that it gives me is n minus 2. I subtract 2, and then I just take that times 180, and that will tell me how many degrees I have inside of the figure, okay? All right, so example 1, they have this figure here. This is not necessarily this is a pentagon. It has 5 sides, but obviously not a regular pentagon, right? All of these angles are not exactly the same measure. Now, it does look like it's symmetric, so this angle measures the same as this one because they're both labeled 2x. This is the same as this one, and then I've got that top angle, right? So I do see that this is symmetric, same on both sides, here and here. But they're not all 5 going to be the same. But what I can figure out is that if I have a 5-sided figure, I have 3 triangles, okay? So, and if we do the n minus 2 times 180, right? 5 minus 2 is 3, and 3 times 180 we said was 540. So one thing that I know is that all of these angles inside of here are going to add up to be 540. Okay, so if I do, I'm just going to add the x's together and all the other numbers together just in my head. So I have 2x here. I've got another 2x, that's 4x. Plus 3x is 7x, plus another 3x is 10x. Okay, so I've got 10x, and then I'm going to add the 142 plus 14 plus another 14. This together is 28 plus 42 is 170, I think. So plus 170, and that's equal to, all of them add up to be 540 is what I got, okay? Then I just do the math from there. So I subtract 170, and 10x equals whatever that is, 370, and divide by 10, and x is going to be 37. Okay, now let's see if they want us to plug stuff back in. Find the measure of each interior angle. Boo. All right, so I know that, if I erase some stuff, I know that my top angle is going to be 142. Okay, I'm going to list these off to the side over here. 142 is one angle, okay? Then 2x and 2x, if I take 36 and plug it in for x, or 37, plug it in for x, I get 74 degrees. So I've got a 74-degree angle and another 74-degree angle. And then if I do the bottom, 37 times 3 is 90 plus 21 is 111. Plus 14 is 125, I think is my bottom angle. 125 and 125. Okay, now, those are all my angles. I've answered the question. This is my final answer. What I can do to check my answers, I can add those up together, and they should add up to be 540. I'm going to do that real quick because I don't trust all my mental math. Give me just a second. $540. Cool. So, final answer, that all the stuff that's in that box. Those are the measures of the interior angles. Okay? All right, next, example 2. It says, here is a really weird design of a house. Not very cost effective. Penny is building a house using a floor plan that she designed. What's the measure of angle ABC? ABC. So they're looking for this angle here, that inside angle, okay? And he is inside of a hexagon, a 6-sided figure, okay? So if I'm going to talk about a 6-sided figure, I do n minus 2 times 180. 6 minus 2 means he has 4 triangles times 180, okay? I think that's 720. Yes, I'm almost sure of it, 720. Okay, so there are 720 degrees if I would add all of these angles up. Now, the deal with this one in particular is that all of these sides are the same, which means that all of these angles are the same. This is a regular hexagon, okay? And when it's a regular hexagon, all of them are going to add up to be 720, and all of the angles are going to be the same, which means I can just take 720 and I can divide by 6 to find out what each one of them is. And when I do that, I get 120. So that the measure of that angle ABC is going to be 120 degrees. Now, that was not true for this one up that we did up here. I could not just take 540 and divide by 5 because all of these were not exactly the same like angle, right? But that is true for this one down here because it is marked that way. Okay, so 120 degrees, that's what I'm looking for. ABC is 120. Done. Okay? All right, if I'm going too fast, please pause, do whatever you need to do. Okay? Let's go to example 3. They do on the left or on the right side here give me what each one of these is named. So a 3-sided figure, you know, is a triangle, a quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. And then these you probably didn't know. 11 was a hendecagon, 12 is a dodecagon, and anything bigger than like 13 or larger would be like a 13gon or a 14gon or a 15gon, etc. Now, if it has like 13 or more sides, it's going to be like almost so flat going all the way around that's almost going to look like a circle completely because it has that many sides. So you rarely ever see anything larger than 12 just because he does resemble a circle a lot because the straight sides are just, you know, like, yeah. All right. Example 3 is switching it around on you. The measure of an interior angle of a regular polygon is 144. Okay, so what I have going on here is that whatever, all the way around, one of those is 144. All of them are 144. I want to figure out how many sides it has to have in order for that to end up being 144, right? Find the number of sides of the polygon. So here's the deal. Here's what we did. We're kind of working backwards, but let's think through what we did. We took the number of sides, I subtracted 2, and I multiplied by 180 to get how many degrees were inside of here. That's what I did to find the 720 in the previous problem, right? I did the n minus 2 times 180. I did all of those things. And as soon as I got 720, okay, this is again from the problem before, so ignore the 720, but I'm just saying, we got 720 in the last problem. What we did then was we divided by 6, right, to get that each one of these was 120, right, in the last problem. So after I have found this number, I'm going to divide by 6 or divide by n, whatever the number of sides that I have, right? I took 6 minus 2 times 180. This gave me 720. And then I divided by 6 to get 120 overall, right? So I'm going to do that same process again, but I'm going to use n this time. And I know that that amount has to be equal to 144 degrees, okay? Not 120. It's going to be 144, okay? So now we have to do a little bit of algebra stuff. This is the formula that I use every time. Set it equal to whatever one of the angles is, and then I'm going to do some algebra and solve. So the first thing I'm going to do is I'm going to multiply by n to get him gone, I didn't cross him out very well, to get him gone to the other side. So I'm going to multiply by n, okay? So on the right side, I've got a mess over here. I've got 144n is what I have for my algebra, okay? Then I'm going to distribute this 180 through, okay? So I've got 180n minus 180 times 2 is 360. And now I just have an algebra problem, right? I've got these three pieces, this one, this one, this one, and I just have to get n by itself. So I'm going to subtract the 180n over here, minus 180n. And I'm going to end up with negative numbers. I've got negative 360 equals 144 minus 180 is going to be negative like 36n, right? And then I just divide by negative 36, and I'm going to get 10. So this means that if I want each angle to be 144, I have to have a 10-sided figure, which is a decagon. Okay? So when you have that going on, this is the formula that you're going to use. N minus 2 times 180 divided by n, and set it equal to whatever your angle is, and then just work backwards, like undoing the problem. Okay? So that's how that works, all right? We've got maybe two more problems. All right, the last one, or the next two, are talking about the exterior angles. Here we were talking about the angles inside of a polygon, right? So like here is my figure. 1, 2, 3, 4, 5, 6. It's a 6-sided figure, so I was talking about what all of those added up to be, right? And a 6-sided figure we've already found was 720. All of those angles are going to add up to be 720. Now, this one is not a regular figure, which means all of those are not equal to each other. So it's not that each one of these is 120, right? That's not true, because some of these sides are way bigger than others. Like this is a bigger side than that. So some of my angles are not going to be the same, right? But we do know that they're all going to add up to be 720, okay? Now, when we talk about the exterior angles, that's like angle 1, angle 2, angle 3. It's like if I extend each side out, like kind of making like a pinwheel fan. You know what a pinwheel is? Kind of making a little pinwheel. I extend each one of the sides out, and then I look for what that measure is inside of that little pinwheel arch right there, okay? If I add all of those up, the rule for interior that we just found, interior angles, the 720, the rule for that was n minus 2 times 180, right? We've been doing that the last couple problems. But the rule for exterior is that when I add up all the exterior angles, they always sum or add to 360 degrees, no matter what, no matter how many sides I have. All of these angles are going to add up to be 360 degrees always. That's just the way that it works, okay? Because the way that this works is that the more sides you have, right, the smaller these angles become, right? So it's not that like when you have a ton of angles, you still have the same degree here in your exterior angles. Those exterior angles become smaller the more sides you have. And so they will always end up summing to be 360, okay? All right, so let's look at some examples down here. They're going to have us calculate some stuff. Find the missing values. Find the value of x, okay? So this is a quadrilateral. We have 4 sides. 1, 2, 3, 4. And we know inside a quadrilateral there's 360 degrees. But also on the outside, each of these exterior angles is also going to be 360. Not just because it's a quadrilateral, but because exterior always adds up to be 360. So I have 6x plus 9x, that's 15, plus 2x, that's 17x, plus the 139 is equal to 360, because 360 is on the outside, okay? Again, don't compare it to the inside. This just so happens to be 360 on the inside as well, but it's 360 on the outside and 360 on the inside. I'm going to subtract the 139, and I get 17x equals, I got to do some math. That's going to be like 21, I think. Yeah, 221 divided by 17. Does that come out nicely? Yeah. If I divide by 17, x is 13. Okay, and they want us to find the value of x, so we're done. X is 13. Okay, I could plug it back in if I wanted to, but I don't have to because that's all they ask. But just remember, exterior angles, they're always going to add up to be 360 degrees. Okay, last question. Example 5, find the measure of each exterior angle of a regular dodecagon. Okay, now, if you need to look at the chart, a dodecagon is 12. Okay, that means it has 12 sides. Okay, so if I draw a picture of my dodecagon, I'm gonna put them over here. My dodecagon, I'm gonna start drawing all 12 sides. So I've got like this going on here, right? This is my dodecagon, and he's gonna be almost looking like a complete circle. But this guy and this guy, if I make my little pinwheels all the way around, I'm trying to figure out what each one of those is. Okay, now notice that it says a regular dodecagon, which means all of the sides are going to be equal and all of these little angles are going to be equal on the outside and on the inside. These angles are all matching and the outside angles are all matching. Okay, so if it's a dodecagon, that means it has 12 sides. And if we're looking for exterior angles, that means I want to know what each one of them is, and they all have to add up to be 360. Doesn't matter how many sides it has, they all have to add up to be 360. And because it's regular, they're all the same. So all I'm going to do is take 360 and I'm going to divide by 12. So that means each one of these angles is going to be 30 degrees on the outside here. Okay. Now, if you want to cheat a little bit, you can find the measures of the interior angles really easy. Instead of doing the n minus 2 times 180 thing, right? We know that an exterior angle has to be 30, so the interior angle has to be 150 because those two will have to add up to be 180. Okay, so rather than doing this route to find the interior ones, you could find the exterior ones and subtract from 180. That's totally a legit thing as well. Okay, so however you want to look at it, there's many different shortcuts to doing these, but these are just talking about however many sides you have, you can find the interior angles and the exterior angles by using either this method or that they always add up to be 360 for exterior angles. Okay, make sure that you're keeping those two straight. Okay, on the homework. Oh, I didn't say which ones to do. Let's do 1 through 4. 1, 2, 3, 4. Do 1 through 4. Let's have you do, I don't know. I will try number 6. 6 looks kind of interesting. And then I don't know. We'll go 8, 10, 12, 16, and 18. Measures of the exterior angles. But then we got to do 20 and 22 yet. Let's do 20 and 22 as well. Yeah, those are exterior angles. So make sure you are keeping track of whether it says exterior or interior. Yeah, that'll work. All right, so let me go back through those again. 1, 2, 3, 4. 1 through 4. We'll go number 6. And 6, 8, 10, 12. 16, 18. 6, 8, 10, 12, 16, 18. So like all the evens, but you can skip 14. Because those ones are kind of icky, hard, long problems. And then 20 and 22. Okay, so however you want to write that out. If you want to go 6 through 22, skip 14, go for it. Okay, there you go. That was a little bit. Okay, all right, so use the rest of the period to work on those, and there you have it.